So today we will discuss some igneous numerical. So first question, calculate the percentage of solid and liquid at point A. So this is a eutectic diagram. So in eutectic diagram we have to calculate the liquid and solid percentage at point A. So this is our initial composition. So initial composition it is given. Initial composition is diapside 82, anorthite 18. So we have to calculate the liquid percentage and solid percentage at A. So liquid composition at A it is given diapside 72, anorthite 28. So this is our tie line. By this it will divide into two segments. So the segment that will touch the liquidus, it will give the solid composition. So we'll draw here. This is our diapside 100. Okay. This will take diapside 82 and this will take diapside 72. So you can also take anorthite. Anorthite will be 0 here, anorthite 0, it will be anorthite 18 and here anorthite will be 28. So I have to calculate the solid percentage. So this segment is solid segment, this is liquid segment. So solid percentage it will be solid segment by solid plus liquid segment. So it will be the solid segment, it will be the difference between the composition at initial composition and the composition where the liquid is. So initial composition is 82 and composition of the liquid where we have to calculate the solid percentage, it is 72. So the difference will be, the solid segment difference will be 10 and this will be your liquid segment, it has a difference of 18. So 10 by 28 into, so it will be 35.71%. This is your solid percentage. So for liquid percentage, you don't have to calculate like this, you can just subtract it from 100%. It will give you the liquid percentage. It will be 64.29%. So at this point the solid percentage it is 35.71 and the liquid percentage it is 64.29. Then comes to the next question. So at X we have taken suppose 150 gram. Now suppose the initial composition that is 82 or 18, it is in liquid condition. So the amount we have taken at X it is 150 gram of liquid. There is a composition of 82 and 18. How much liquid were lost when the composition reaches at point A? So if this is the initial composition, the crystallization will begin at this point when it will touch the liquidus. So from this point to this point only diapside will crystallize. So the amount of liquid lost from this point to this point is equal to the diapside crystal that formed from this point to this point. So here we have calculated that 35.71% of diapside is formed from this point to A point. That means from total melt, 35.71% solid is formed and this much of liquid is lost. So the amount of liquid lost, the amount of liquid lost is equal to the amount of solid formed. So amount of solid or percentage of solid, it is 35.71% of the total liquid. So to solid it will be 35.71% of 150 gram. So it will be 150 into 0.3571. So it will be 53.565 gram. So this much of diopside or crystal is formed, and you can say this much of liquid is lost from this point to this point. Next comes to how many moles of diopside will form at point A if initial liquid was 540 gram at point X. Now the composition is all same. The initial liquid amount, it was 540 gram. So you have to calculate how many moles of diopside will form at point A. So at point A, we have calculated the percentage of solid, it is 35.71. So this much of solid or this much of diopside is formed till point A. So from the initial melt, now 35.71% is your diopside. So I have to calculate the amount of diopside. The amount of diopside, it is 540 into 0.3571. So it is 192.834. So it will be 192.834. So this much of diopside, it is formed at point A if initial composition we have taken 540 gram. So now the question is asked, how many moles of diopside will produce at point A. So this much gram of diopside it form at A. So first we have to convert this much of diopside, we can say amount here, to mole. So we are getting this much gram of diopside at this point. So just we have to convert this amount of diopside, the weight of diopside, into moles. So number of moles we can calculate. Number of moles we can calculate by this formula, given mass divided by molar mass. So given mass, it is here 192.834. So we have to calculate the molar mass of diopside. So we know the composition of diopside, that is CaMgSi2O6. CaMgSi2O6 will be 188 gram. So number of moles will be given mass. The molar mass of diopside we have calculated 188 gram. So it will be divided by 188. So it will be 1.025 moles. This much moles of diopside will form at point A. So this is a simple question. First you have to calculate the gram of diopside that form at A from the initial composition, from diopside 80 to anthracite 18, which was 540 gram. After calculating, so you just have to convert this mass into number of moles. Then comes to next question, how many grams of solid will form if composition X, this 300 gram, will undergo fractional crystallization? It is asked after the completion of fractional crystallization. So if we have 300 gram of solid, 300 gram of melt, it undergo fractional crystallization. So at the end of the crystallization, how much solid we will get? So first thing you have to remember, during fractional crystallization, the last melt composition or the last melt percentage will be the final solid percentage. This is the concept here. So the last melt composition is the final solid composition in case of fractional crystallization. So in eutectic, the last melt we will get at eutectic point. The last melt will get at eutectic point. So the initial composition is diapside 82, diapside 82. So this is our eutectic point. So here diapside will be 58. So we know the eutectic composition of diapside anorthite. It is diapside 58, anorthite 42. So this will be diapside 58, this will be 82, this will be 100. So we have to calculate the liquid percentage at point E, because the liquid percentage at point E will be the final solid percentage. Because before that all the solid will be removed by fractional crystallization. Only the last melt will be the final solid composition. So this will be your liquid segment, this is solid segment. So I have to calculate the liquid percentage. So the liquid percentage at eutectic point will be liquid by liquid plus solid into 100. So here liquid will be 18, thereby liquid plus solid, this much will be 42. Will be 42, this much will be 18. So 18 by 42 into 100. So it will be 42.85%. The liquid percentage is 42.85%. So the initial composition we have taken initial melt. It was initial melt was 300 gram. So at eutectic point 42.85% melt is remain from the initial melt. So melt at eutectic point, it will be 300 into 0.4285, 42% or 0.4285. It will be 128.55 gram. So this much of melt is present at eutectic point, and this is the last melt. So this much of solid it will form after completion of fractional crystallization. This comes to calculate the amount of melt diapside will form if at B there is 200 gram of solid. So this is a point B. It is in solid field. So we have 200 gram of solid here. The composition is the same, diapside 58, diapside 82, anorthite 18, but it is in solid field. It is in solid condition. So if that will undergo melting, then how much diapside will form? So remember, if this solid it will undergo equilibrium melting, then the composition of solid and composition of melt will be same. That means if diapside 82, anorthite 18 solid will undergo equilibrium melting, it will produce melt of composition same diapside 82, anorthite 18. So this is during equilibrium melting. In case of equilibrium melting, the composition of the solid is equal to the composition of the melt. So that means simple 18% of what is asked amount of melt diapside. That means 82% of diapside, 82% of diapside of the initial composition will be found in melt after melting. So we just have to calculate the melt amount of diapside after melting. It will be 200 into 0.8 will be 160 gram, because the amount of dioxide is present in the solid will be equal to the amount of dioxide present in the liquid or melt after equilibrium melting. Then comes to if the composition B will undergo fractional melting. If it will undergo fractional melting, then what will be the amount of melt form? So always remember, in case of fractional melting, the last solid composition will be the final melt composition. So the last solid composition will be the final melt composition. So if this composition will undergo fractional melting, so the the melting will start at this eutectic temperature, it will 1274. So then at this point the melt it will form will be removed from the system, along with you can say anorthite. So we have to consider it from the theory that the amount of dioxide is present here and anorthite present here. They will start melting at eutectic temperature. So then the amount of melt produced at eutectic temperature, it will be removed from the system during fractional melting. But here at eutectic temperature, dioxide will partially melt, but anorthite will completely melt. So because of that, all the anorthite will be removed from the system and only dioxide will remain here. So that the dioxide that is present at eutectic temperature or at eutectic point, you can say, will be the last melt composition, will be the, you can say, final melt composition. So you have to calculate the solid percentage at eutectic point for this composition. So we have to calculate the solid or dioxide percentage at eutectic point. So it will be, this much will be 18, this will be, total will be 42, this will be 82 minus 58. So solid percentage will be 24 by 42 into 100. So it will be 57.14%. So 57.14%, this much of solid will form at this point, or this much of solid is left at this point during fractional melting. So this is only dioxide. All the anorthite will melt at eutectic temperature. So this much of dioxide from the initial solid, that is 200 gram. So the amount of solid, or you can say dioxide here, it will be 200 into 0.5714 4.28. So this much of dioxide will be left here, because all of the anorthite will melt and partially some dioxide will melt at eutectic temperature. So this much of solid during fractional melting, it will melt at 1392 degree. So it will, after eutectic temperature, it will melt at 1392 degree. So the complete melting will happen here, and after melting you will get this much of melt, because at eutectic point we have this much of solid left. So the amount of melt after fractional melting you will get 114.28 gram, because after eutectic point there will be no melting until unless 1392 reach. So that's why there will be no, you can say, removal of melt from 1274 to 1392. So that's why the amount of solid you will get at 1274 will be completely melted at this temperature only. It will not melt in between these temperature 1392 to 1274. There is a melting hiatus here, because at eutectic point during fractional melting you will get pure dioxide. there will be no anorthite. All the anorthite will be melted at eutectic temperature and will be removed from the system because of fractional melting. So at 1392 you will get this much of melt, that is equal to the solid form at eutectic point. Then comes to calculate the melt composition at point B. So it is saying this B, not this B. So you have to calculate the melt composition at point B. So calculate, and also calculate the amount of diopside melt present at point B if initially there was 900 grams of liquid at point Y. So now we have initial composition point Y. So we will take here initial melt composition, it is Y, which is diopside 20, anorthite 80. Then it is asked at point B, it is 60. So melt composition at point B, it is diopside 40, anorthite 60. So first we have to calculate the melt composition, melt percentage at point B. So I have to calculate the melt percentage. Okay, this is little melt composition, but we will calculate the melt percentage. So melt percentage at point B. So this is anorthite 100. Okay, this is, you can say, anorthite 80. This is anorthite 60. So this will be the liquid segment, this will be solid segment, because this will liquid and this will be solid segment, it is touching the liquidus. So you have to calculate the liquid percentage. So liquid percentage, it will be liquid by solid plus liquid into 100. So liquid is 20 by 40 into 100 will be 50%. So here you will get 50% of liquid and 50% of solid. Then it is given next part, it is given we have 900 gram of initial melt. So we have to calculate the melt percentage of diopside at point B. So see, so for Y composition the crystallization will start at this point when it will touch the liquidus, and from this point to this point only anorthite will crystallize. There will be no crystallization of diopside. That means the initial amount of anorthite, the initial amount of diopside that present in the melt will be remain same up to point B, because there will be no crystallization of diopside here. So we just have to calculate the initial melt amount of diopside, that will be the melt amount at B, because there will be no crystallization from this point to this point, no crystallization of diopside. So the melt percentage of diopside in initial melt, it is diopside 20, or you can say 20%. So melt amount will be 900, 20% of 900, 0, 0. Will be 180 gram. That means at Y point initially it was 180 gram of diopside, as it will not crystallize till point B, so the amount will remain same. So we don't have to calculate the melt percentage here. So the initial percentage of diopside will not change, initial amount of diopside will not change up to B, or you can say it will not change up to eutectic point, because for this composition diopside will crystallize from eutectic point, not before that. So from beginning of the crystallization up to eutectic point, the diopside amount will be remain 180 gram. After that it will change. Next comes to a solid composition of diopside 54 anorthite 46. So this is our solid composition. So it is diopside 54 anorthite 46. These are solid composition. This is undergo fractional melting. So when it will undergo fractional melting, the melting will start at this point at 1274 degree temperature. So how many grams of anorthite will be separated at 1274 degrees? So the amount of anorthite will melt here, that much will be separated. So you have to calculate the melt composition here first. You have to calculate the melt composition first. First we have to know how much melt will produce at 1274 degree. So the amount of melt that produced at 1274 degree, that will be separated during fractional melting. First we have to calculate the melt percentage. So melt percentage at eutectic point. Melt percentage at eutectic point. So it will be, this is anorthite 100, this is diopside 58, and this is diopside 54. So I have to calculate the melt composition. So this will be liquid, this will be solid. So the liquid percentage will be, so the liquid composition will be diopside will be, the liquid segment will be 54, and total segment it will be this 58 into 100. So 54 by 58 into 100, it will be 93.103%. This much of melt will produce here, and it will be separate from the system. So what will be the amount of melt? So amount of melt, it will be 93.103% of the initial solid we have taken. That is, initial solid is 600 gram. The 600 gram into 93.103%, it will be 558.618 gram. So this much of melt will be produced at eutectic point, and it will be separate from the system. So this much of melt contain both diopside and anorthite. It contains both diopside and anorthite. So the composition of the melt, it is diopside 58, anorthite 42. So any solid you will take, they will start melting at 1274 degree, and the first melt they will produce at eutectic temperature will have a composition diopside 58, anorthite 42 always. You take any solid composition. So from this melt, we have 50% is your diopside. So the diopside melt, it will be 558.618 gram of melt into 58%. So 58% of the melt is diopside, and 42% of the melt is anorthite. So it will be 323.998 gram. So this much of diopside will be separate at this eutectic point. So this much of melt completely separated, from which 323.998 gram is your diopside. So come to next question. So from the solid solution diagram, calculate the percentage of plagioclase melt. Plagioclase melt means your melt percentage, and plagioclase crystal, that is crystal or solid percentage. So you have to calculate at point A and C. So initial composition is our X, so that is your anorthite 60%. So first we have to calculate the percentage at point A. So at point A, this is your A, this is B point. This A point has anorthite 40%, and B point anorthite is 72%. Okay, so you have to calculate point at x, that is initial composition, which is anorthite 60. So this segment is our solid segment and this segment is our liquid segment, because the segment that touches the liquidus, it is solid segment, and it will the segment that touches the solidus, it will be liquid segment. So first I have to calculate the solid percentage here. Solid percentage, it will be 20 divided by 62.5% solid. So you have 62.5% solid, then liquid percentage will be 100 minus 62.5%. So it will be 37.5%. So at point A, the solid percentage is 62.5 and the liquid percentage is 37.5. Then it comes to at point C. It comes to at point C. At point C, you have anorthite, it is 50. Anorthite is 50. At D point, anorthite is 85. So we have to calculate at point C. So initial composition is your anorthite 60, that is your initial composition. So liquid percentage, we'll first calculate the solid percentage, then we'll subtract it from 100%. Solid percentage, it will be 10 by 35 into 100. So this will be 35, this will be your 10. It will be 28.57%. It will be your solid percentage. Then liquid percentage, it will be 100 minus 28.57. It will be 71.42% approximately. So this is the solid percentage at C. This is solid percentage at C and liquid percentage at C. Then comes to the next part, calculate the amount of anorthite solid from formed when the melt reaches at point A. When melt will reaches at point A, if initially we have taken 500 gram of plagioclase. So initial melt, it is your 500 gram. So you have to calculate the solid, anorthite solid form. How much anorthite solid will form when melt reaches at point A. So first we have to calculate at point A the solid percentage. I have already calculated that at point A solid percentage is 62.5%. At point A solid percentage is 62.5%. So from the initial melt, from 500 gram, you can say from 500 gram 62.5% is solid. So the solid will be 500 into 62.5%. It will be 312.5%. Sorry, 312.5 gram. This much of solid will form at point A. This much of solid will form at point A. So the solid, it contains both albite and anorthite. So the solid is plagioclase, so it contains some percentage of albite and some percentage of anorthite. So the amount of anorthite here will know from the composition of the solid here. So at point A, the amount of solid will form, the amount of solid or the composition of solid, it is given by through this tie line at B point. So the composition of solid form at point A it is your anorthite 78%, anorthite 78%. So the amount of solid form at point A, it has 78% anorthite. So the amount of solid, it is from 312.5 gram, from which 78% is your anorthite. So the amount of anorthite, it will be 312.5 into 78%. It will be 243.75 gram. This much of anorthite will form at point A. Now, so how many grams of plagioclase crystal will form from point C to point A? So first we have to calculate the percentage of solid at point C. Then we have to calculate the percentage of solid at point A. So we have already calculated that percentage of solid at point A, it is 62.5%. Then percentage of solid at point C, it is 28.5%, you can say, approximately. So from this point to this point, how much, what percentage of solid is crystallized? You have to subtract them. 62.5% minus 28.5%. It will be 34%. So from C point to A point, 34% of the solid or plagioclase is crystallized. So this much of solid will form. So initially we have 900 grams. So from 900 gram, 34% is crystallized from C point to A point. So 34% of 900 gram will be the amount of solid that produced from C to A, with 306 gram. So this much gram of solid will produce, this much gram of plagioclase is produced from point C to point A. When it comes to magma at a depth of 400 km has density of 2.3 gram. So here magma is present at 400 km depth, which has a density of, you can say, 2.3 gram per cc is given. Then it is rising through this column of rock. Having density 2.9 gram per cc. So you have to calculate how much high it will rise from this depth. So I have a formula, which rho r into d equal to rho m into h. So d, it is the depth, h, how much it will rise from this point to upward. So rho r we have to calculate h. So h will be rho r into d divided by rho m. So density, they are dividing each other, so they will cancel the unit. So no need to change the unit or no need to convert the unit. So up to 2.9 into d, it is 400 divided by 2.3. It will be 50.347 kilometers. So from this point to, it will rise up to 504.347. It is a theoretical thing. It will not rise, literally it will not rise, just for calculation it will rise up to 504.347 kilometer from the segregation depth, you can say, from this depth. Because granitic magma originates at a depth of 500 kilometer. So magma, it is originate at a depth of 500 kilometer. Now the depth is 500 kilometer. So it rises upward through a rock column having average density, it is given 3 gram per centimeter cube. Here the average density, it is given 3 gram per centimeter cube, and the density of the magma, it is given 2.998 gram per centimeter cube. So we have to calculate how high it will rise from the surface, not that how high it will rise from this depth, how high it will rise from the surface. So first we have to calculate h. So apply the same formula, rho r into d equal to rho m into h. So h will be rho r into d. So rho r is given 3 into d, it is given 500 divided by 2.998. So it will be 1500 divided by 2.998. So it will be 500.333 kilometer. So magma will rise this much height. That means this will be your 500.333 kilometer. So from the how much it will rise from the surface? You have to subtract it from 500 kilometer depth. That is minus 500. It will be 0.333 kilometer above the surface. So this much it will rise above the surface. So from the depth it will rise up to 500.333 kilometer. So above the surface it will be 0.333 kilometer. Comes to a basalt weighs 3 kg, has density 2.5 gram per centimeter cube. So mass is given 3 kg, it will be 300 gram. Then density it is given 2.5 gram per cc. We have to calculate the volume. So you know density equal to mass by volume. So volume equal to mass by density, 3000 gram divided by 2.5 gram per cc. Maybe 1200 cc centimeter cube. 1200 centimeter cube.